All right, on the calculator part, there's going to be some word problems. Remember, for the word problems, you get to use your formula sheet. So you will have all of those formulas given to you. So you just need to know which one to use. So the first one says you're investing all your earnings in a summer job. So this is the amount you're starting with. You find an account that will pay 0.8% compounded weekly. So when you see that word that it's compounded weekly, you are definitely going to use the compound interest formula, which says you take your initial amount times 1 plus the rate over n, the number of times it's compounded a year, times t. So that's the function you're using. So with ours, they're investing $700. 1 plus the rate is 0.8%. So if it's 0.8%, I have to move that 2 places, so it's going to be 0.008. Remember, you have to take that decimal point and move it 2 places. So it's 0.008 over n, and if it says it's compounded weekly, there are 52 weeks in a year. And I want to know how much I'll have after 5 years. So again, it's P times 1 plus R as a decimal over n raised to the n times t power. All right, so then you just have to throw that in your calculator. Couple ways you can do it. What you might want to do is start with the parentheses first, because that's the order. So 1 plus 0.008 divided by 52. The calculator will do the division before the adding. That's the number I get. Now I'm going to raise it to the 52 times 5 power. So in my calculator, I have to put it in parentheses, 52 times 5. Some of your calculators, it will take that answer and raise it up so that all of that will be in there. To be safe, put it in parentheses. And so I take that answer, raised to that power, I get 1.04, and now I need to multiply it by 700. So just, you can throw them in several ways if you use your parentheses, but I usually just start with this, get my base, raise it to that power, and then multiply by 700. So at the end of 5 years, I will have $728.57 if I round that. So $728.57. You should round to the nearest cent because we are talking about amounts of money. All right, so that's if it's compounded. If you look at number 22 says a population of deer has been decaying. So first of all, you need to know then it's getting smaller and it's decaying continuously. So if it's a compounding continuously, then we're going to use the continuous compounding, which is A equals P times E raised to the RT. Now if it's decaying, you're going to have a negative R value. If it's increasing, it'll be a positive R value. So I'm going to say, if there were initially 500, that's my P value. I'm starting with 500. It's continuously, so it's E raised to the R, which is, again, move that 2 places, negative 0.017 times T. And it wants to know how long will it take so that there's 400 deer or less. So I want to know when the final amount is 400. So I start with 500. My rate, it's continuous, so it's a base of E. My R value is negative 0.017 because it's getting smaller. I want to know the time that it will be 400. So how do I solve that equation? I first divide by 500. Remember, you got to get this base by itself. So if I take 400 divided by 500, I should get 0.8. Okay, so you first have to get the base by itself. Now I have to put it in log form because I have this exponent. I want to solve for t. I have to use log. So log base e, so that'll be natural log of 0.8 equals my exponent, which is negative 0.017t. So I'm saying log base e of 0.8 equals my exponent. Remember, the logarithm always equals that exponent. And now to solve, I'm going to divide by negative 0.017. So on my calculator, I need to take, do that over here, I'm going to take natural log of 0.8, I'll get my answer to that. So if you did that already, you should have had negative 0.2231. And now we divide that by negative 0.017. And I get about 13.1 years. And I know it's in years. I know it said continuously because it said a continuous rate per year. So that's why I know it's in years. So final amount was 400. Initial amount was 500. There's my rate. It's negative because it's decaying, and I want to know the time t. So to solve that, I have to get the e raised to that power. I need to get the base by itself, then put it in log form, and then solve. Okay, so that's a problem like that one. Number 23 talks about the each year one. It's saying the value of your car decays, so again it's getting smaller, at a rate of 8% per year. Okay, so that's when we're looking at this where it says it's decaying by a certain percent each year or each hour. So we're going to use this formula. So the initial amount, you paid $8,000 for it. So that's $8,000. You're going to do 1 minus your rate because it's decaying, and if it's 8%, I move that 2 places. I get 0.08 raised to the t, and it says if you paid $8,000, how long? So you're looking for time. How long will it take until it is $5,000? So again, I start with $8,000. That's the initial amount. 1 minus the rate, 0.08, because it's decaying. I want to know when, so I want to know the time when it gets to be 5,000. So to solve this, again, I need to get this base by itself. So I need to divide by 8,000. So I need to take 5,000 divided by 8,000, and I get 0.625 equals, I'm also going to take 1 minus 0.08, and that's 0.92, just so that's easier to write. So instead of 1 minus 0.08, I'm writing it as 0.92. Divided by 8,000 to undo that multiplication. So now I need to put it in log form. Log base 0.92 of 0.625 equals my exponent t. So it's the log base 0.92 of 0.625 equals t. And if I solve that, remember to do that in my calculator, I'm going to take the log of 0.625, log 0.625, either close your parentheses or hit enter, divide it by the log of 0.92. And I get 5.63 or 4, I guess it is. And it says when, so I'll say 5.6 years. All right, and then the last one, we're using our Newton's law of cooling formula, which is here. It says you are making a cake, you put it in the oven at 350 and pull it out of the oven. So that is the T, the initial temperature, the T sub 0. So I know it was initially at 350 degrees. The temperature of the room is 64, so that's the T sub R. The temperature of the room is 64. So I put that in those 2 places. When you return 22 minutes later, so when the time is 22, it has cooled to 86. So when I have a time of 22, I have a temperature of 86. So initial temperature, if you look at your formula, initial temperature was 350, 64 was the temperature of the room. I don't know R, but I know the time was 22 minutes. At 22 minutes, the temperature of the object was 86. So this time goes with whatever that temperature is. So after 22 minutes, I was at 86 degrees. All right, to solve that, I need to figure out what is 350 minus 64. That's 286 e to the 22r. And actually it says negative there. If you look at your formula, it's negative RT, so I'll put that as a negative. I need to subtract 64 on each side, so 86 minus 64, when I subtract on both sides, is 22. So first of all, that becomes 286. I subtract 24 on each side, and I get 22. Have to get the base by itself, so I divide by 286. And 22 divided by 286 is 0.0769. I'll go four places. Equals e to the negative 22r. Convert it to log form. Natural log base e of 0.0769 equals negative 22r. And now I just need to divide by negative 22. So I'm going to take natural log of 0.0769, hit enter or close your parentheses, divided by negative 22. R is 0.1166, which is 11.66% if you want a percent. It doesn't really say, it just says find the rate. So I would accept either of those answers.